In today's video, I'm going to assemble a Banggood LM317 adjustable voltage power supply. This is a low power device for powering up small projects. It's not a bench supply, but it certainly is good enough for low power bench projects. So the people at Banggood sent me this, and I'm going to show you guys how to put it together. I received this package today from Banggood.com. This is a power supply kit that I'm going to build on this video. And, well, let's take a look at the package. But here's what's in the bag. A smallish little transformer, but this is not going to give us a lot of power. What this is, though, is it's an adjustable power supply. Comes with a little plastic box to put it in. We get a bag full of parts. And a basic instruction manual to show me where to put the parts. Looks like there's 4 resistors. 4 different values of resistors, and an LM317 adjustable regulator, digital display to show the voltage, small little circuit board. Circuit board looks to be pretty good. And it is stenciled as to where to mount the parts. So let's get building this. So C1 is this other one here. So we'll mount C1 in place. Okay, so C2 and C3 are going to be small ones. They're little 0.1s. That's these little ceramics, and they are not. These ones are not polarized. purpose of the small little 0.1 microfarad capacitor in parallel with the large electrolytic is it's to take out any high frequency noise, any RF and so forth that might be induced that could cause the regulator to not function properly. So that's a filter for high frequency component, and the bigger capacitor is to filter out the ripple from the rectification. In case you guys are wondering what I'm doing to hook up the meter, I'm just pulling the actual jacket off of the wire because I don't need the whole colored jacket on here now. Exposing the copper wires, we'll just twist the wires together so that they're together. And then I'm going to tin just the end of it so I can use it to thread down through the hole, and that way it'll be connected down to the board just like the other two are. So I'm just going to tin the tip of the wire ever so slightly. That way the wires don't fray, they stay together. And then I can use my needle nose pliers, bend it around and thread it through the hole, like threading a needle. And then I can pull it through from the bottom. And that way the wires are nicely connected, like that. and I don't have to worry about short circuits or anything because the wires are pulled tight. This meter's never going to be taken off the board. So now it's connected. So that's the meter. Now let's mount the regulator IC onto the heatsink. I'm just looking for an appropriate screw for it because I've got some big screws and little screws, and I don't know if I've got too many screws here or not, but one of these might be threaded into this back. Yeah, these ones are threaded. So, okay, we're going to put a bit of heatsink compound onto the heatsink tab. Now the regulator IC is attached to the heatsink. I can go ahead and mount that on the board. The 3 terminals going through the board. And then the 2 pins of the heatsink going through the mounting holes. I think that is all of the components except for the terminals. We've got a couple of terminal strips here that have to go on. There's a 3 bank terminal and a 2 bank terminal. So there's the 3 bank terminal, and next to it the 2 bank terminal, like that. We'll solder those down. So the red wires are the primary. So we're going to hook the secondary wires up here to the secondary input. The one's marked AC. Polarity is not important here because it's AC. Now that all the components are mounted, can put the IC in now. The IC is identified by the notch. Pin 1 is in this top corner here, and that's going to go in this way, facing towards the regulator, where the notch is also indicated on the board here. Nice thing about socketed ICs is that if you ever have to change them, they're easy to take out. Okay, now time to hook up the AC power cord. Bring the heat shrink tubing up over top of the splice, and then we'll heat it up and seal it. So here's where the instructions become a little less clear, because it doesn't tell me much about this thing other than the fact that I put all the parts on the board. and I've hooked up the power cord. So let's plug it in first of all and see if we get anything. Okay, well that's a good sign. It's turned all the way down and it's showing me 1.16 volts. So if I adjust the control, as you can see, the voltmeter goes up to 13.8. So it's adjustable between 1.16 and 13.8. I have no idea what the LEDs represent because I don't read Chinese. I don't know what their voltages are. Let's just measure the output of this thing and just see whether the voltages are, whether the meter is correct. And I don't even know which of the inputs and outputs on this. It's got these 5 terminals, but I don't know what they do. Okay, the meter's hooked up and the voltage is fairly accurate. It says 3.04, my meter's showing 3.1. So it's fairly close. If I set this to 5 volts, my meter's showing 5.05, and this is showing 5.04. So it's fairly close. Now my meter's showing 5.08. If I set this to 12, my meter's showing 11.9. There we go, 11.9. We set this up to 13.8. Yep, 13. Okay, this is jumping up and down a bit, and as you can see, my meter is also jumping around a bit. 13.9 volts. It's pretty close. 14.5. It seems to be jumping around with that light flashing too, like the load of the light blinking. I have no idea what these stupid blinking lights are all about, so I'm going to go look this thing up. And I'm going to put the case together on this thing, but I don't know what these other terminals are for. So I have a feeling they're to make the buzzer buzz and stuff, but I don't really know. If I put a resistor light between 2 of them here, the buzzer will start to beep when I get over a certain voltage. Right. And I don't know what this other pot is, whether it's that could be to adjust the frequency of the buzzer for that matter. I don't know what it does, but let me just try something here. Oh, that's adjusting the frequency of the light flashing. So I don't know what that is. Maybe that's a warning if you go over a certain voltage. Okay, I think I figured out what these lights are for. These are just basically these 3 terminals here. One of them can operate your buzzer, depending on what signal you give it. And for example, if I tap it here, and the yellow light looks to be flashes with the oscillator, and the red light will indicate whether it's a high level and the green light whether it's a low level. So you can, I've just tied 2 of the pins together here, and this is very vague. I'm kind of looking at the schematic, but DS3 is the one that goes to the buzzer, which is this one here. So these are your outputs. 1 is your positive, 2 is negative, 3 is the buzzer input, which basically just turns the transistor on and off to make the buzzer buzz. 4 is the output from the oscillator, which you adjust the frequency of the oscillator with this control here. And DS5 is an input, which is this one here, and that will control whether your light is red or green. So, whoops, So if I disconnect the output here, for example, if this is pulled low, it should turn the green light on, which it does. And if it's pulled high, it will turn the red light on, which it's on now. And the yellow light will flash at the rate that you set this oscillator. So if we put if I just put my jumper between pin number, the middle pin here, 4 and 3, it'll beep with the beat of the yellow light. The red and green light is determined on what is being fed in. So you can use this as a basic logic analyzer. It'll switch the red to green depending on what's coming in here. So you can generate a square wave signal that you can set the frequency with this pot. So in other words, these don't really serve any function. It's just for blinky lights. If you like blinky lights, you can tie 4 and 5 together. And it'll do that. And then you can set the frequency. So you can have your blinky little lights. Really doesn't serve much purpose, does it? The blue light is your power on. So here are the pieces for the cabinet. They've all been cut and they've got their protective paper on them still. So let me just peel off the paper here, and then we'll get to assemble the cabinet. Now time to get all the dust out of it. Wipe off the inside of the cabinet before I put the top on. One last piece to go on here. That's the top cover. Top cover goes on like that. It's held in place with, looks like 3 more screws. They go down like that. And of course, these would be ones that if you push them in too far, you're going to drop them inside and have to take the top off it again to get the nut out. So we'll try and not do that. There's one. There's 2. There should be one more screw here somewhere. But if I'm missing one, too bad. There's 2, and I think there should be one more little screw here, but I don't see it. All I see is a big one. Got a couple of these big screws, and I don't see any more of the little ones. So I'm missing one screw, but big deal. It's together. I even got their little sticker I can put on here. I'll stick it on the bottom of it. I think it's a sticker. It's a sticker. There you go. Banggood. It's assembled. Plug it in. There it is. It's working. What's perfect here is I can power up my little clock. The last module I got. There you go. It's powering up my last little kit that was supposed to arrive as a kit, but it didn't. It arrived assembled but not working. Anyway, there you go. That's the power supply kit. We'll catch you in the next one. I've got a couple more kits coming from the same place, a couple clock kits. One's going to be a propeller clock, I believe. But anyway, I got 2 clock kits coming, and this is the first of 3. And I've got a Nixie tube clock that I'm going to be building, and that wasn't a giveaway. That was one I had to buy, and it was a lot of money. But that'll be fun to do that too. We'll catch you in the next video. Bye for now.